electron notations of ions, atoms that have a charge on them. Calcium +2, sulfur with a -2. Let's do the calcium first. Whenever anything has a charge on it, it has gained or lost electrons, specifically electrons. Even if it's a cloud and it's a lightning strike, it is a gain or loss of electrons. Recall the basic structure of the atom. The electrons are on the periphery or the outside of the atom. That's the easiest thing that can be removed or taken away or added to. So this calcium atom has lost those electrons. Let's fill in the electrons on our periodic table and then erase 2 of them to write the electron configuration of this. So we're going to fill in our electrons on our periodic table up until we get to the box that neutral calcium lives in, alternating up, down, up, down, up, down, up, down. I got a magnesium, I got another row. Up, down, up, down, up, down, up, down. Yes, so calcium's 20. So this is the box that neutral calcium is in. This, we filled it up to calcium. This is calcium with a 0 charge or a neutral charge. Because it has a +2 in this example, we are going to erase the 2 outermost electrons. So now this periodic table represents the electrons that calcium with a +2 adds on. We have our S shell. We have our P shell. So to draw out our electron configurations, I'll try to keep my colors straight here. We have 18 electrons to account for. There is a 1 S, and there are 2 electrons in there, so I'll do that in green. And then there is a 2, and I'm just reading left to right and going down like you're reading a book. 2 S2, 2 S2, and then reading across 2 P6, 2 P6, and then there is a 3 S2, and then finally a 3 P6. There are 18 electrons in our picture here, and there are 18 electrons in those superscripts. So that's the complete electron notation for for calcium with a +2 charge. Let's do the same thing for sulfur with a negative charge. I'm going to erase my electrons here. So anything that has a negative charge must have gained electrons. Let's draw in sulfur neutral and then add dose electrons. Up, down, up, down. I'm starting up. If I started with down, that would also be fine too. It's the alternation. Up, down, up, down, up, down. So that is the sulfur box right there, and it has a -2 charge. So I'm going to add 2 electrons. Okay, this looks very familiar here. I should have thought about this examples before I put them up there, but this is identical in electron configuration to calcium +2. They are of different charges because of the number of proton and electron ratio here. But to write this out for calcium, 1s2, 2s2, 2p6, 3s2, 3p6. These atoms have identical number and arrangement of electrons, different charges because of the number of protons that are in the nucleus. Hope this helps. Thank you.